At the top of the next page, we move into our next way that we can find zeros, this time finding zeros from intercept or factored form. We just went over how to find zeros in graph form. If we're given the graph, we just look for the x-intercepts. When it comes to finding zeros from intercept or factored form, our job is pretty much as easy as it can be, and that is because what intercept form does, in fact the reason that intercept form is called intercept form is because intercept form puts the parabola's intercepts front and center. They are actually just right there in intercept form. So you will recall that intercept form is this: f of x equals a times x minus p times x minus q, same thing as y equals all of that stuff. Well, it just so happens that p and q are going to be the zeros or intercepts. So basically, whatever is in this position after the first x and whatever is in this position after the second x, those are going to be your zeros. Technically, the opposite of those are going to be your zeros. So quick example, if I had something like x minus 3, x plus 4, well, if I put this into pure intercept form, which you will notice has a minus there and a minus there, we have x minus 3 and x minus negative 4. And then if we sort of match everything up to intercept form, we have x minus p corresponding to x minus 3. We can see that the p is in the 3 and the p are in the same position. And then over here we have the q and the negative 4 in the same position. So again, whatever the opposite of this is, we know the opposite of negative 3 is 3, and whatever the opposite of this is, the opposite of positive 4 is negative 4, these two values will be the two x values at which this function will equal 0, and therefore those values will be our zeros. So in the case of example number 5, let's go ahead and look at this example. You might want to do this one on your own. Pause the video and come back and join us when you are finished. So in example 5a, we have the function f of x equals 2 times x minus 3 times x plus 4. And we want the roots of f. Remember that roots are exactly the same thing as your zeros or your intercepts. So what did we say? We said we take the opposite of this. We said we take the opposite of this. And those are going to be our two zeros. In fact, those are the same two as up here. That was just coincidence, I promise. So opposite of negative 3 is positive 3. Opposite of positive 4 is negative 4. What is the product of the solutions to x minus 3, x plus 0.4? So again, we're just going to take the opposite of this. So one of our zeros, one of our solutions, remember solutions is synonymous with zeros, we are going to write x equals 3. That's the opposite of negative 3. And then we are going to write x equals negative 0.4. Those are our two solutions. Those are our two zeros. They want the product of those. So we are going to be doing 3 times negative 0.4. We are not allowed to use our calculator here, so we're going to have to do this in our heads. What is the best way to do this? Probably to do 3 times 4, which is 12. Remember that we need to move our decimal over one place to the left, so we're going to get 1.2, and of course we have a negative there, so that is negative 1.2 will be the product of the solutions there. Next, example 5c, if y equals all of this stuff, what is the least value of x for which y equals 0? Well, remember, yet again, another one of those synonymous ideas or synonymous terms. When we talk about y equaling 0, that just means the x values that will produce a 0 over here, which means, again, we're looking for the zeros. That's what zeros are, the x values that make y equal to 0. So our zeros here are going to be opposite of this, which is negative 0.5. Opposite of this, which is negative 0.1. Opposite of this, which is negative 0.3, and they want the least of those values. The least of those values will be the largest negative. It's going to be that negative 0.5. If you're having trouble seeing that, there's various ways that you could help yourself out. One way is to just plot these values on a number line. There's 0, there's negative 1. Well, negative 0.5 is going to be there. Negative 0.1 is going to be, let's say, there. Negative 0.3 there. That's obviously not drawn to scale, but whatever. Negative 0.5 is going to be the least or the farthest left point on the number line. So negative 0.5 will be the least value that will produce a y value of 0. Now, we just talked about this very simple case where we have pure intercept form. And in pure intercept form, there are no coefficients other than 1, of course, in front of the x value. So when that is the case, when the coefficient of x is 1, again, we can just use this, take the opposite of the thing after the x's approach, which again is what we did here. Opposites of the numbers or variables after the x's. However, if there is a coefficient other than 1 in front of the x, we're going to want a more robust, maybe a little more technical way of extracting the zeros from the quadratic. And that will be using that method will be the zero product property, which is a very simple idea. It basically says that if you have two things that multiply to give you 0, one of those two things has to equal 0. Either A has to equal 0 in this case, or B has to equal 0. Technically, they both could equal 0 as well. But that's the only way you can get a zero product. One of the two things that you're multiplying has to be equal to 0. So in the case of a quadratic that looks like this here, if we are trying to find where this f of x or y value will equal 0, and we have our two factors written like this, we know that one of these two factors needs to equal 0. That is the zero product property. If we were multiplying two factors and getting 0, one of those two factors has to equal 0. So the way that we can figure out what values of x will produce this 0 is by finding out what value of x will produce this 0. In other words, we can just set each of those factors equal to 0, then solve for x, and then we will have our zeros. So in the case of example 6, let's try this out. We are going to use the zero product property to find the zeros of this quadratic right here. So we know that if we are multiplying this factor by this factor and getting 0, one of those two factors has to equal 0. So 3w plus 7 has to equal 0. By the way, that's what they're asking us for, the solutions here, which, as we've said many times, solutions pretty much the same as zeros. Obviously, when your equation is set equal to 0, we're looking for the values of w in this case that will make our quadratic equal to 0. 3w plus 7 equals 0. Negative w plus 4 equals 0. And now solving for our variable in this case, which is w, we take the 7's away. We get 3w equals negative 7. Divide by 3, and we get w equals negative 7 over 3. Over here, we're going to subtract 4 from both sides. We get negative w equals negative 4. Obviously, we can divide or multiply by negative 1, change both of those signs to positives. So our two values of w that will make this equation true are the values that will make this equal to 0 or this equal to 0, and those two values are negative 7/3 and positive 4. So negative 7 over 3, semicolon, positive 4. Those are the values of w that will satisfy that equation. Higher degree polynomial, one that has 3 x's or an x cubed. What we are going to do, though, is the same exact thing. If we need to know where this graph, this is what they're asking, what values of x will we intersect the x-axis? Well, remember, intersecting the x-axis is synonymous with y equaling 0. That's what happens when we intersect the x-axis. Our y value is 0. So really what this is asking us is what values of x will satisfy this equation where all of this stuff over here equals 0, where all of this stuff over here makes our y value, or in this case h of x value, equal to 0. So all I'm going to do is use the zero product property. I know that 2x or 3x plus 2 or 4x minus 5 must equal 0. So 2x equals 0, 3x plus 2 equals 0, 4x minus 5 equals 0. Again, I'm just setting each of those factors equal to 0. Divide by 2, divide by 2. That one's simple. I get x equals 0. Minus 2, by the way, 0 over 2 is not undefined. Some students do make that mistake. 2 over 0 would be undefined. 0 over 2 is just 0. So this is a doable division here. Minus 2 minus 2, we get 3x equals negative 2. We divide by 3, we get x equals negative 2/3. That's our second 0. We add 5, we get 4x equals 5. Divide by 4, we get our third 0. So the values of x that will make this function intersect the x-axis, in other words, make y equal to 0, will be 0, negative 2/3, and 5/4. Those are the, that's ugly, those are the zeros in this case.